I'm going to use plt.xlabel, and that will, I'm going to set that to years. And I'm also going to use plt.ylabel. I'm going to set that to revenue. And finally, plt title, which will be revenue over the years. And I'm going to showcase what I have with plt.show. And as we can see, revenue over the years, years, and revenue. And down the line, if you want to explore your data visualization skills and sharpen them, you can even do a lot of things. Like, for example, here you can set like a font weight to semi-bold, let's say. And perfect, you have years in bold. You can even change the font size to something like 12, let's say, or like 18 to make it, this will look a bit ugly, but just to showcase it for pedagogical reason. So yeah, there's a lot of things that you can do in your different data visualization toolkits and Python, and make sure to check out some data camp courses there while you're still on the platform for Free Week. So now the other thing that we can do is not just visualize over the years, but visualize over months and years to just see if there's any seasonality that we may need to think of. Now, what we did here is that we grouped by order year. What we want to do is do the same thing, but repeat the same process, but for order year month, which we created here. So going down, I'm just scrolling slowly. So I'm going to create a new data frame named sales by a year month, right? And I'm going to use sales date, which is what we already did here to create the data. And I'm gonna group by without an underscore, order underscore YM, which is the year month column that we did. I'm gonna use sum. As a reminder, we need to reset index here. And finally, let's print out the header of my data. And perfect, you can see that for each of those order year M column, we have a great order. We have aggregations based on the year and the month. Now, what I want to do is I want to visualize it using a line plot, because line plots are excellent to visualize seasonality. So what I'm going to do first is, because we have tons of data and we have many years and months, I'm going to make this plot quite bigger. And I've done this through experimentation. You don't need to know exactly any of the units, but just for good measure, we use the plt.figure function, which lets me control the entire figure being outputted here. And I'm going to use the fig size argument, which takes in a tuple, which is 1 horizontal units. I've set those to 18 here, and 6 to vertical units. Again, I've tried this with trial and error. You don't need to know 100% of how your data looks like, of how your plot will look like. Now, what I'm going to do is I'm going to add a line plot. And similar to bar plots, it takes in an x-axis with a string of the column name, a y-axis with a string of the column name, and the data. So if you can guess what the x-axis will be here, it will be the order YM. On the y-axis, again, we want to visualize the total due. And the data is the sales by year by month data frame. Awesome. And then what I want to do is add the the X label years, and I want to do as well as add the Y labels. Sorry about that. So that would be revenue. So actually, just do years and months. And then what I want to do is add the title, revenue over years and months. Right, just making it a bit more consistent here, removing the capitalization. And then I'm going to just add plt.show, and you're going to notice that there is something that's going wrong with this visualization. which is essentially the x-ticks, or what is labeled on the x-axis. What I want to do is I need to rotate the axes here, and what I'm going to do it with the plt.xticks function, and it takes in just one argument for my purpose here, which is rotation, and I want to rotate it by 45 degrees, so it just takes a 45 number here, and as you can see, a perfect representation here. This basically concludes our first question and the report that we're making. Now what we want to do is actually repeat really similar steps, at least from a syntax perspective, and what we're doing to Q1, or the first question. Now the second question is, how is revenue divided by channel type overall and over time? So we did impute the channel type column for a reason, and this is where it's going to come in handy. Again, as a reminder, the channel type column, what it represents is whether a sales order ID is a business-to-business order, i.e. another business purchase from us, or a B2C order, which is business to customer, which means that a customer directly purchased a bike from us. The first thing that I want to do is I want to take that channel type column to the sales sheet, and what we're going to do is really repeat the same steps that we did last time by using merge and group by. And let's do so. So first thing I'm going to do is I'm going to create a new sheet named sales_customers. So just to showcase this particular data here. So I'm going to merge sales on customers. I'm going to merge them on the unique column between them, which is sales order ID. And I'm going to do a how equals left join. So I'm going to join customers from the right of sales to the left immediately. And then let's just print out what we have. Perfect. So now we have a channel type for a sales order ID and also a total due, which means that I can segment by channel type and see how different channels are performing. So let's do so by first identifying the revenue and amount sold by channel. So for the revenue, we're gonna create a sales by channel. So actually, to take a step back, what we're going to do is do a group by channel type. And what we're going to do is take the sales customers data that we created here and group by channel type, because what we want to do is compare each channel type's performance on an aggregate level. I'm going to sum, and to not forget, reset index here. So let's check out the sales by channel data frame. Awesome, I get for B2B, B2C, the total number of revenue and the number of items sold. So let's create a bar plot function, visualize it using a bar plot, and I'm gonna use the sns.barplot function, just similar to how we used it earlier. X-axis takes in the channel type, Y-axis takes in the total due. My data is sales by channel. What I want to do as well is add the X label channel type and the Y label revenue, and the title for my slide, revenue by channel. And let's showcase what we have with plt.show. So apparently we have made a mistake here by using plt.label, not plt.ylabel, and now it is perfect. So yeah, the results pretty clearly demonstrate that B2B provides more revenue than B2C, but is there like a temporal dimension to this? Can we also group by channel type and by date? This would require merging the sales date data frame that we created particularly, just going back slightly here. So this is sales date. We merged dates and sales, and essentially what we want to do is do another merge and add customers as well. So I'm gonna have a sales customers date data frame, which again, like, let me print the header here of the data frame just to remind you. So sales date head. This has been commented out here. So yeah, sales date head, you can see what I want to add here as well I want to add data on the channel type, which is present in the customers sheet. So what I'm going to do is sales date here. I'm going to merge customers on the sales order ID, and my how is going to be left. So essentially, I'm going to take customers, merge it to the left, take it to the left, and add it to sales date. And I'm going to visualize the header of the resulting data frame. So sales customers date. And you can see now that we have for each sales order ID, an order date, a ship date, an order year month, customer first names, employee last names, and finally the column of question channel type. Now what I want to do is see whether there is a difference in revenue performance by channel type by year. So how can I do that? So how can I aggregate by two columns? It's actually quite simple. When I'm going to create a new data frame named sales by channel date, which is similar to what we did here when using group by. And I'm going to take the sales customers date. I'm going to group by two columns instead of one, order year and channel type. So now, and I'm going to chain it with sum, similar to how I've been doing, and I'm going to reset index. And to visualize how that column looks like, we can see that indeed we have an order year, a channel type, and a total due column, right? But now how do we visualize a bar plot where we have two groupings of data as well? Also, just a small additional argument to our bar plot function. So if I was doing a regular bar plot, similar to how we've been doing earlier by just visualizing year on the x-axis, the channel type on the x-axis, or the channel type on the x-axis, we can, for example, look at order year here on the x-axis, y equals total due, and data, sorry about that, and data is sales by channel by date. Let's visualize what we have. Sorry about that. And we can see here that we have a bar plot. The lines here are just representative, are just added sometimes when we have to discuss a statistic to Matplotlib. What I want to do here is I'm going to add to the hue argument, just to group by B2B and B2C, a grouping which is channel type. So what this does is that it represents, it groups, it allows me to visualize my data according to a certain grouping or a hue. So here what I'm doing is on the x-axis we have the date data, on the y-axis we have the total revenue data, and by adding hue equals channel type, we're able to segment each bar to whether it's a B2B or a B2C purchase. Now, what we're going to do is clean this up a bit just to make it a bit more presentable to a business audience. So what I'm going to do is I'm going to take the .xlabel function that we've been used to doing, and I'm going to set it to order year. And I'm going to take the Y label. I'm going to set it to total revenue. And for the title, I'm going to set it to channel type performance and revenue based on over years. And now we have a form of title. We can increase the font of the title. We can improve the visualization here, remove this, but it's not part of the scope of today's session. Just know that you can do almost anything you can think of when visualizing data in Python. Now, ultimately, we have reached the final question we have before the end of today's session. So the final question today is, who are the employees responsible for the most B2B sales overall and in 2013? So just a small reminder, we have created already a sales customers date sheet, which has been used, I believe, in Q1 and Q2. So when we were merging sales with customers and in dates, so now we have created this. What we want to do as well is take this data and just really group by employee full name to see how the different performance has been and visualize. And we'll also learn how to segment on 2013 and isolate 2013 values to visualize as well using a bar plot. So let's start off. We've already done the VLOOKUP part here in Q2, which makes our life a bit easy. So let's start off with the sales employees sheet, which is essentially an aggregation that we're creating. So just to remind you guys of how sales customers date looks like. So it contains the data of the 3 sheets: sales, customers, and dates, all in one data frame, and we've grouped them all in question 2. Now what I'm going to do is I'm going to create an aggregation based on employee full name that we created here in the first early pre-processing steps. So sales employees, I'm going to create this aggregation data frame. I'm going to take sales, customers, and date, just removing the extra space here, group by, and it will be full name as we created here. And what I want to do is sum and preset index, similar to how we've been used to doing. And let's print out the sales employees header. So as we can see, we have Amy Alberts, David Campbell. We can see the total due for each person and the number of items sold per each person. Now, what I want to do, hopefully, is to be able to visualize by order from smallest to highest. And what we can do in order to do that is just use the dot sort underscore values method of a data frame or a column of a data frame. Sorry. And the way we do that is just use, let's say, for a data frame TF1, it has the dot sort values column method. On the by argument, it takes the column name being sorted. Ascending takes in true or false, dependent on whether we want to sort it by ascending order. In our case, we do want to send it by ascending because we want it from lowest to highest. Also in place, similar to how we use it in drop, just lets us set the changes immediately in place without having to overwrite a new object. So let's take a first start. So I already created the sales employees sheet here. What I want to do is just order by total due to be able to visualize correctly. So sales employees, here we can see it. I'm just using the tab to make my life a bit easier. I'm going to use sort underscore values, right? The first argument, as we discussed, is the column name. So that's total due. I'm sorting by revenue. Do I want it from smallest to highest? Yes, I do. So I set ascending equals to true. And do I want to overwrite my changes instead of having to create a new object? Yes, I want to do exactly that. So I'm setting in place equals true. Now, you can even print the header of this newly created sheet, and we can see, as you can see in the indices, we have Sayed Abbas is the lowest one, Rachel Valdez moving on forward, etc. And now it's on us to visualize this particular sheet. So the first thing I'm going to do is similar to how we did in the line plot, because we have a lot of data. I'm going to set my figure size using PLT figure. Fig size equals similar units, so 18 and 6. I'm going to do as well a bar plot that takes in as x-axis the full name, on the y-axis the total due. Sorry about that. And on the data, it's my sales employees sheet. All right, what I want to do as well is I want to add a X label, which says employee full name. I want to add a Y label that says revenue, and I want to set a title that says B2B revenue by salesperson. Right, and finally plt.show, but you will also see that there's a problem with the rotations. So what we can do is use the .xticks function, rotation equals 45, and we have a solution. And essentially now we have been able to visualize our B2B revenue by salesperson. We can see that Linda Mitchell is definitely the MVP of her company. So now what we want to do is see whether there is a temporal dimension to this, and I want to particularly isolate the years, the performance of employees in 2013. So what we're going to do is essentially I'm going to recreate a new sales employees data frame, but this time grouping by not only by the employee full name but also by the order year. So sales employees, I will take the sales, sorry about that, customers, date sheet, group by, and this time since I'm grouping by 2 columns, it takes in a list that uses this bracket notation, employee full name, as well as order year. And I'm going to string it along with sum, chain it with sum, and never forget the reset index. And finally, I will print the header as well. Oh, I added an employee full name, not the full name column. My apologies for that. I made a mistake with the full name column here, but we do see full name, order year, etc. Now what we want to do is sort the values to make them more readable. What we want to do is sort them by year and by revenue. So we'll take a look at how that's done. So we do sales employees, sort values using the sort values method, and it takes in a list as well because we're ordering by 2 columns, so order year and total due. What this will do is that for each employee, it will order from 2011 to 2014 and then order the total due. And I'm going to set sending equals true. I'm going to set in place equals true, and then let's see how that looks like. So sales employees, head, and we have a small typo here and another typo here with the, sorry about that. And now we have reached full name, order year, number of items. As you can see, typos are part of the game when you're writing a notebook. It's completely normal as long as you just like take a look at the error value that you have. So yeah, as we can see, we have now a data frame that has ordered years, where for each employee we have the year, and also that is ordered by total due as well. Now, what I want to do is isolate only the values of 2013. So the way we can do so, I'm going to create a data frame named sales employees 2013. I will also do it in order to isolate the order year, right? What I'm going to do is I'm going to take sales employees, use the bracket notation here to be able to subset. And what I'm going to do is I'm going to isolate all rows of order year that is equal to 2013. And the way we do inequality in Python is by using a double equal sign, not just one equal sign. So here, this is a condition that says sales employees order year is equal to 2013, and I am subsetting on this particular condition. And now I can show you this data. And you can see that we only have 2013 data. Now, the final step is to just visualize. And again, since we're having almost the same exact visualization as here, only for 2013, we're going to be using really similar steps. So fixed size equals to 18 and 6. I'm also going to be using a bar plot, which takes in on the x-axis the full name, on the y-axis the total due, on the data the sales employees 2013 data. PLT x6, I will set the rotation to 45. On the PLT x label, I will have the employee full name. On the PLT y label, I will have total revenue. On the PLT title, I will have B2B revenue by salesperson in 2013, because this is the data that I'm visualizing. And finally, doing a PLT.show, and we can see as well really similar data from 2013 to overall, which means that there's not much variability in performance over the years, at least in this particular data set. This really marks the end of our notebook, and now we're going to move on to a Q&A session. So what is the difference between df1 merge and pd.merge? Essentially, I think they do the exact same things, and it's just two different ways to do the same thing. So one question is regarding joins. So what if the match column ID are different? So essentially, there are two interpretations to this question. And I'll give you an answer for both interpretations. So let's say here I'm gonna go to a merge. Okay. The first interpretation is what if they have differently named columns? So for example, sales date equals sales.merge. Let's say there's no common sales order ID column between them. What you can do is that if you're sure these are the same columns, just rename the columns. Secondly, if the second interpretation of your question is, what if I have a sales order ID column, but the IDs are different for some reason, yet I know that they are close or similar. This especially happens when you have data frames with no unique identifiers. And what if you want to join them? I would suggest looking at something called record linkage, which lets you join data not on exact matches, but on similar matches in a string similarity. For example, let's say you have a column that has my name Adele and someone else's name, and another and one data frame, and another data frame has Adele with the E. These two would be similarities. Yet there's a lot of different parameters to think about when you do this. If you want a course that teaches this, actually I've taught a course on DataCamp named Data Cleaning in Python. Chapter 4 covers record linkage. When using the group by method, is it possible to change the number format at the same time to make the data easier to see? I'm not entirely sure I get this, but I think it has to do with the total due column not being a +0.5. Yes, you can change it quite easily in pandas, even when you're doing visualizations. I think it would just need to convert either the item to an integer, depending on your use case, or you can just set the decimals a lot more. Can you export Python graphs onto a PowerPoint presentation? Yes, you can just copy paste the image, save the image immediately from your notebook. Is it possible to embed a live code for the same so that it updates automatically? One thing you can do is you can create a, I know that we used to do this in the previous company I worked in. We used to have a scheduler that runs a Jupyter notebook each Monday for the purpose of a report, and I think that schedule can be written in just an easy bash script or something along those lines. Can you explain more closely the hue parameter in Seaborn? Of course. So let's go back here. Let's say I want to visualize order year on the x-axis. On the y, I want to visualize total revenue, but I want to showcase different groupings of my data. The hue axis is the hue argument is great to showcase different groupings of my data. So, for example. In this example, what I'm visualizing on the x-axis is the order year, the y, the total revenue, and I'm segmenting by channel type. And this is where the hue axis goes in. Now for the another question is, can you show us how to specify a color palette for the graphs? Yes, you can. There's really a multitude of ways to do this in Seaborn or in Matplotlib, and more than one way as well. I'm pretty sure you can use, for example, color equals green, let's say, and red, and values is probably G and R. Yeah, there's a few arguments that you can use in Seaborn or in Matplotlib. Seaborn color palette. That would help you out here. In case you're interested in DataCamp courses that could help you do so, please check out the data visualization courses as well as any of the blog posts we have on DataCamp, and as well as a live training that I led recently on data visualization and how to improve coloring there. You can also to add to your question, you can also set styles. For example, let's say I want to removing this particular color here, I want to do SNS set, I think it's white, or set style. For example, this will change slightly how your theme looks. You can even choose the economist theme, etc. There's really a lot of different ways by which you can improve your visualizations. Is it best practice to create a new data frame using .groupby before plotting, or should we use groupby on original data frame within the plot arguments? You can definitely use that if you want to. I was just, for pedagogical reason, to make it look a bit cleaner. This was done today. Can you please again explain the reset index? 100%. So essentially, let's say here I'm gonna do this without reset index, and this is perfect because it's on a multi-column data frame, on a multi-index data frame. So essentially here what we have is these columns are considered indices. Pandas is quite tricky when you work with indices sometimes. For example, if I type in the index attribute here, I get a multi-index 2011 B2B, 2011 B2C, which just lets me know how can I index my data frame. Now, since I want to visualize on the x-axis the order year, so let's say I kept it like this, here my visualizations will not work because I could not interpret input order year, right? So we need it to become its own column. The way we do so is that we just reset the index, telling pandas that these columns need to be actual columns, and that the index could be just an auto-generated 0, 1, 2, 3, 4, 5, similar to how you see it in spreadsheets. It's an added nuisance, but at one point in time, using indices actually really help you when you want to locate a particular data. What is the benefit of building charts this way in Python when Excel can create charts and modify them much easier and easily auto-update them? I do definitely get the concern that sometimes creating visualizations on Python could be considered much more verbose than in Excel. However, I would respond with this. Let's say I'm creating this report on a weekly basis where I have to get new data each in. All what I have to do, for example, is just change the data here. Sorry for the scroll. And apologies, just at the beginning of the data frame, the notebook, and just run the notebook completely from scratch. And then I have an updated data. One other thing is that once we've reached a level of data fluency that is enough to power like certain pieces of software, like creating dashboards for your organization or your team, so to be able to make these reports much more visible for everyone, this is where these data visualization skills will come in point. How would I start using this Python system with my company data for work? So if you have a CSV file, Excel file that you have, all you need to do is install Python in your own machine, which I think we've covered a lot on DataCamp as well with the free blog posts. So installing Python. So for example, yeah, as we can see here, Python developer setup, or even how to set up a data science environment, how to set up a data science environment for your machine. And you can look at something called Anaconda, which is just really one thing to install, and it will get there for you. Can I add a trend line in the plots? Yes, 100%. You can really, I would say, do almost whatever you want in visualizations, as long as it's computationally makes sense. All right, guys, so I think it's time to move on. So really a pleasure to have had this notebook. I just want to end this session with a few different things to consider when we're thinking about data science. So what we did in today's session, essentially by bridging the gap from Excel or spreadsheets to Python, is we learned a few things. We learned how to import an Excel file with multiple sheets into Python by using the .excel file function from pandas, or the pandas.read Excel. We learned how to explore our data sets using the info method, the describe method, the unique method. We learned how to clean and add new columns. We used the replace method, the toDateTime function, the lock method, and a few help to one get confused as I thought it. It's worth, and especially in data science, it's not necessary to have that solution memorized, but what's really essential is to be able to discuss this problem and ask the right questions. And this is where Google comes and is really essential. For example, we can see here that just 2 different Google searches for the same thing lead to different results just based on how to phrase a question. And secondly, there's a lot more blog posts that you can check out on Stack Overflow and of course DataCamp courses while you're here. And as well, like just from a mindset perspective, understanding your errors and developing the patience to address them, and having the self-empathy and accepting that not knowing the answer is okay, and becoming curious about it and finding it is really half the way to really growing in data science and becoming more data fluent and keeping on learning. Now, before I leave and before we introduce the take-home question, I just want to remind you guys, this week is free week. Share this, please. We've had such an amazing response from all learners across the world. We have had 63,000 new people join us over this week, over 6 million total registered users. Really, just the amount of growth and change that we've had ever since I've joined DataCamp to now, it keeps on. It's crazy, and it keeps me humble, and I'm really humbled by the response that we've had to a lot of these live training sessions as well as in free week. So please if you think this was a nice session, or if you like what you've taken so far on DataCamp, make sure to share this with your friends and coworkers and family. Also, if you want to, apologies for that one. If you want to, we have a small error here with the slide. Let me just remove that for you guys. Also, if you have more courses to take on, please, to become a Python expert, please take on the data science toolbox, the data scientist, the data analyst, data manipulation, skill tracks and career tracks, and make sure you keep on growing. And finally, we also have the For Everyone courses. So if you're not really interested in learning how to code, but want to understand data science, make sure you join these courses, and including the most recently released one, Data Engineering for Everyone. And finally, more live training. So this Thursday on 3 p.m. Eastern Time, we have a Getting Started in SQL session that's taught by Kelsey. Kelsey, she introduced today's session. And we also have next week a data analysis in Excel. So if you want to keep on using Excel, we also got you covered. Now, before we drop this question, before we end today's session, essentially we have a small take-home question. So based on the sheets that you've been working with, you need to answer the following question. Who were the highest earning and compensation salespeople in 2012? Make sure some clues for you before you submit your solution. You need to use all the 4 sheets. You need to calculate the commission earned by each employee, which is essentially the amount of revenue they generated by their commission percentage. You need to sort the results by amount of commission earned, and finally visualize visualize your results. And definitely bonus points if you make your chart extra pretty, which requires some research, and using syntax that is not covered in this session. Now, please share with us a code snippet with your output on LinkedIn, Twitter, or Facebook, and tag DataCamp or me at Adol_Neme with the hashtags DataCamp Live and DataCamp Free Week, and you'll definitely get a shout out. So again, thank you so much, everyone, for all the engagement, and thank you for everyone who attended today's session. I hope you got something out of it. And Kelsey, I guess I'll let you take the rest.
All right, thanks, Adele. That was a wonderful session again, as always. Again, thanks everyone for.